Now, students, we try to understand the classifications of colloids or colloidal solutions on the basis of physical state of dispersed phase and dispersion medium. Number one, if dispersed phase is solid, dispersion medium solid, types of colloid solid sol, example some colored glasses and gemstone. Second, solid, liquid, then it is said to be sol, paint, cell fruits. Solid, gas, then it is said to be aerosol, smoke and dust are the example. Liquid, solid, when liquid is dispersed in solid as a dispersion medium, then it is said to be gel, example cheese and jellies. Next, liquid, emulsion, milk, hair cream. Liquid gas, it is also known as aerosol, example fog, mist, cloud, etc. Gas, solid, solid sol, pumice stone, foam, rubber. Gas, liquid, and it is said to be foam, example froth, miss foam, or soap, leather, and whipped cream. These are the complete classifications of colloidal solutions or colloid on the basis of physical states of dispersed phase and dispersion medium. I think that all of you understand the entire classification of colloids. Now, student, we try to explain another classifications of colloidal solutions on the basis of nature of interaction between dispersed phase and dispersion medium. Actually, the dispersed phase and dispersion medium forms interaction between them. On the basis of these interactions, they are categorized in two groups. Number one, lyophobic sol and or lyophobic colloids. Second one is the lyophilic sol or lyophilic colloids. Lyophobic. Lyo means liquid, phobic means heading, liquid heading. That means it has no affinity with the dispersion medium. And to preserve this kind of colloidal solution, they require stabilizing agent. For example, sulfur sol, gold sol, and they are irreversible in nature. That means when stabilizing agents are removed, then they are easily separated from each other. Next one is the lyophilic colloids. So, first of all, once again, try to understand the definitions. Lyophobic sol, particles of colloidal phase have no affinity for dispersion medium. Rather, they hate dispersion medium. They are not easily prepared and they need stabilizing agent for their preservations, are known as lyophobic sol. Lyo means liquid, phobic means heading. Example, sulfur sol, gold sol, silver sol, ferric hydroxide sol, etc. They are also called extrinsic colloids. They are irreversible in nature. So these are the first type, and now we try to understand or try to discuss the second type, which is lyophilic colloids. Now, student, try to understand the another type, which is lyophilic sol. That means liquid loving. So, in this case, colloidal particle have a strong affinity with the dispersion medium, and they itself acts as a stabilizing agent. So, there is no needs of adding extra stabilizing agents. So, the definition of lyophilic sol is particles of dispersed phase have strong or great affinity for the dispersion medium. They are self-stabilized because of strong attractive force operating between the suspended particle and the dispersion medium. So they are acts as a self-stabilizing agents, are known as lyophilic sol. Example, starch sol, gums, albumin. They are reversible in nature and they are also known as intrinsic colloids. So my dear student, several times this type of questions are asked in the board examinations. Define the term lyophobic colloids or sol or lyophilic colloids or sol. So please remember all the times, lyophobic colloids means when the particles of colloid have no affinity with the dispersion medium, then they are said to be lyophobic colloids. If they have a strong affinity with the dispersion medium, then it is said to be lyophilic colloids. So all of you please remember the definitions along with the examples of lyophobic sol or colloid and lyophilic sol and colloid. So hoping that all of you understand this type of classification of colloidal solution. Now students, we discuss about the classifications on the basis of particle of the dispersed phase. Number one, macromolecular colloids. When macromolecule, that means bigger molecules, are subjected to dissolves in a suitable solvent, then they start to disintegrate and achieve the particle size of colloidal range, then it is said to be macromolecular colloids. Example, protein sol. Protein is a bigger molecules, so when it is dissolved in suitable solvent, then it start to decompose and achieve particle size of colloidal solutions, then it is said to be macromolecular colloid. That means bigger molecules converted into the particle size of colloidal range are known as macromolecular colloids. Understand? Now student, try to understand the second type, multimolecular colloids. When large number of atoms or smaller molecules are aggregated, are associated to achieve particle size of colloidal range. What is colloidal range? 1 to 1000 nanometer. Then it is said to be multi means many, multi-molecular colloid. Multimolecular colloids. Example, sulfur sol, gold sol, etc. These are the examples of multimolecular colloids in which large number of atoms and smaller molecules get associated or aggregated together and achieve particle size of colloidal range, then it is said to be multimolecular colloids. And now we discuss about the third one, which is associated colloid. Number 3, associated colloid. Associated colloid. There are some electrolyte which acts as, there are some substance which acts as normal electrolyte at lower concentration. At lower concentration, but when aggregates and achieve particle size of colloidal range are known as associated colloid. Now student, what are the associated colloid? There are some substances which behave as electrolyte at lower concentrations, but when their concentrations increases, then their ions start to aggregate and achieve particle size of colloidal range. Such kind of sol are known as associated colloid or associated sol. Example, soap sol. So example, soap sol, which is also known as micelles. Example, soap sol or micelles, M-I-C-E-L-L-E, micelles. How does micelles formation takes place? This is the valley dirt, and then around the valley dirt the soap molecules aggregated in this form, COONA plus, COONA plus, COONA plus. This is the molecule of soap. This is the COONA plus. They forms cluster in this manner, and this cluster is known as micelles. This is the clusters, minus plus, COO minus Na 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 plus. This is the micelles, and micelles are the colloidal suspensions of soap molecules. And once again, micelles are the colloidal suspensions of soap molecule. This is the soap molecule which associated with the valley dirts in this manner, and the structure formed is known as micelles. Micelles play important role. Micelles formation play important role in the cleansing of cloth, because when micelles are agitated in water, then it broken into small globules, and these globules washed out in the current of water, and we get clean cloth free from valley dirts. So we discuss further right now, but today we discuss about the micelles. Micelles are the colloidal suspensions of soap molecules. Now we discuss about the another topic which is related with this. Number 1, CMC, critical micelles concentration. It is the optimum concentrations at which micelles formation takes place. The optimum concentrations at which micelles formation takes place is known as critical micellization concentration, in short CMC. Another topic which is Kraft temperature, the optimum temperature at which micelles formation takes place is known as Kraft temperature. So in today we discuss about the colloidal solution. What are the colloidal solution? Colloidal solutions is a heterogeneous system containing particle size of dispersed phase in order of 1 to 1000 nanometer in a dispersion medium. So colloidal solution consists two component, dispersed phase and dispersion medium. And then we explain the types of colloidal solutions, in which we discuss about the emulsion, aerosol and the gel. In aerosol, dispersion medium will be gas. In emulsion, dispersion medium will be liquid. So entire details are written and explained in the video. So please all of you with the given video. And then we discuss about the further classifications on the basis of interaction between the particles of dispersed phase and dispersion medium. On this basis, there are two types. Number 1, lyophobic sol. Number 2, lyophilic sol. In lyophobic sol are those sol in which particles of colloid have no affinity with dispersion medium. So these kind of salts are obtained in the presence of stabilizing agent. Example, sulfur salt, ferric hydroxide salt. Second one is the lyophilic salt. Lyophilic salt, philic means attractions or love. So in this case, particles of colloid have a strong or great affinity with the dispersion medium, and they do not require any kinds of stabilizing agent, are known as lyophilic salt or lyophilic colloids. Example, star salt, gum, gelatin, etc. These are the examples. And then we discuss about the multimolecular colloids, macromolecular colloids and associated colloids. Multimolecular colloids, in which the large number of atoms and smaller molecules get aggregated together or associated together and achieve particle size of colloidal range. Example, sulfur salt, gold salt, etc. Next, I discuss the macromolecular colloid. Macro means bigger. In this type, when the larger molecule or macromolecule such as protein are dissolves in a suitable solvent, then in them they start to disintegrate. In daily life, when you put tablet of discipline in water, then it start to convert into the colloidal solution. So it is also examples of macromolecular colloid, you can say in this way. Last one is the associated colloid. There are some substances which serve as normal electrolytes at low concentration, but when concentrations increases, then their ions start to aggregates together and forms colloidal solutions, are known as associated colloids. Example, soap salt or micelles, all of you understand. And there are two terms related with the formation of micelles. Number one is the Kraft temperature. Number two, CMC, critical micellization concentration. Kraft temperature, the optimum temperature at which micelles formation takes place. And Kraft temperature, all of you understand. Now CMC, the optimum concentrations at which micelles formation takes place. For example, suppose that you have one bucket of water and then you added only 1 spoon of detergents. There is no micelle formation takes place. When you added, then a condition is then at which micelles formation started. That is the CMC. Okay, hoping that all of you understand and enjoy with this video.